Hello everyone, welcome to this video. My name is Amir Sinahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to do coastline monitoring in the Google Earth Engine platform using MODIS images. Let's go to the Earth Engine code editor environment using JavaScript programming language. So for the first step, you need to identify the region of the interest. My region of the interest in this tutorial should be a region covered by the water. It could be a lake or coastline, in the oceans, in the gulfs. It doesn't matter where you are going to do this process. The only thing is matter is you need to select an area covered by a water. So, for example, first of all, I'm gonna select a lake in my own country in the northwest of Iran, Urmia Lake, that highly desiccated over the last 20 years. And now in the first step, I'm gonna show you coastline monitoring for the lake, for this lake, and then I will show you how we can use this method for the coastline in the open seas and the gulfs and the rest of the regions in all around the world. And one thing is important, and one important thing is this tutorial could be useful for all around the world because the data, platform, Earth Engine, everything is free, publicly available in all around the world. So let's go to the tutorial. First of all, we need to identify the region of the interest through the drawing tools available here. For example, simply I'm gonna select my region of interest through rectangle tools available here. Draw my rectangle, and then through the mark.center object, I want to have focused on the study area that is defined as geometry in my code. So in the next step, we need to call MODIS surface reflectance data. MODIS surface reflectance data. So in the first step, in the next step again, through the search places and dataset, you will be able to go through the various datasets available in the Earth Engine, and every day is updating and you can have access to unlimited satellite images available there. So, and just type MODIS surface reflectance, just like that. MODIS surface reflectance, all the products including surface reflectance words showing here, and some of them for Terra and some of them for Aqua. As you know, the MODIS is a unique sensor carried by Aqua and Terra satellites. Terra data is available since 2001 and Aqua is available since 2022, mid 2022 actually. So, and some of them are daily and some of them are 8 days products. The main difference I mentioned regularly in the previous tutorial in my YouTube channel, that 8 days product is the 8 days products or any other multi-temporal products provided more accurate data because of less cloud cover and less noises compared to the daily version. So it is available with 500 meter or 250 meter, and in this tutorial, as we are going to do coastline monitoring, it is important to use the data with good temporal frequency and enough spatial resolution and a fair spatial resolution. 250 meter is good for us in this tutorial. So if you need a more higher spatial detail for your map, you would be better to use this process using Landsat or Sentinel. In this tutorial, I'm gonna have focus on the MODIS product, but I will try to make some tutorials for the Landsat and Sentinel data. So let's see in future. I will publish some videos in this regard. So now through the Terra surface reflectance 8 days product with 250 meter, we continue our processing. So image collection imported, make a new variable. So in the first, actually, I'm gonna compare the coastline in 2001 between 2001 and 2023 actually, to see that how much the coastline changes during, for example, 22 years or 23 years. So let's see how it works. The first variable is MODIS MOD for 2001 equals to, assign the image collection to modis 2001 and then set the filter date. So as this variable is specifically used for 2001, the start date is 2001 and the end date will be 2002. So next, throw the dot map unit, throw that map, make a loop to calculate normalized difference water index, this time according to relationship between red and near infrared region of electromagnetic spectrum. Why? Because the surface reflectance products I'm using has 250 meter and only including red and near infrared region of electromagnetic spectrum, and we couldn't use the green band or band number 5 in this tutorial because it has 500 meter spatial resolution. That's why we have to use relationship between red and near infrared instead of green and near infrared. So let's see how it works. So inside the map, make a new function and each input image consider it as an IMG here, and then we need to make a variable as bands equals to through each input image. We want to first select desired bands starting with these letters, the surface. So, and the rest of them, the rest of letters doesn't matter, like this. And then we need to multiply the scale factor. If you go to the bands descriptions here, bands here, you can see that we have a scale factor like this that should be applied on each available bands. The applying a scale factor before calculating spectral indices is very important things, because helping you to range the your surface reflectance value from the original range to the actually surface reflectance true range, actually, because now they have a false range of value that should be converted to a true range of values by this scale factor. So after scaling is done, so now make a new variable as variable ndwi equals to gets bands, and then normalized difference calculates the normalization relationship between red and near infrared. Actually, in contrast to the NDVI, we use the normalization between near infrared and red. For the NDWI, according to the red, we have to use the red and near infrared like this. The first input band is the red because it has higher reflectance in the water, and the next band is near infrared because it has the lower reflectance in the water surface. So then dot rename, helping us to change the name of band to the NDWI, and for the next step, this function returns a final result that is NDWI with the properties of input images, but we don't need the properties of input images in this tutorial, but we used to copy input properties for the outputs. But the main thing is that the copy properties only is important when you want to do the time series analysis. Here, just I want to do the change detection according to two single images for two specific year, and no need to use the copy properties, but we used to do it in our processing. And also if you write or remove it, no difference in the calculations. So, and then after calculating NDWI, we need to produce an average image using that median. Actually, the median helping us to reduces the remained cloud cover or extreme values coming from the cloud cover or noises in the satellite images, and most of the time will be useful for the analysis. So through that median, the image for 2001 is created, the median NDWI image for the 2001, and then through the map.add layer, you will be able to visualize the surface reflectance for 2001. Here, map.add layer, modis for 2001, clip it based on the region of the interest, and then leave the visualization parameters empty, and then in the layer setting names write the MODIs for 2001, the layer names, and use the false at the end, helping you to avoid automatic load of final results because it highly reduces the speed of processing in the Earth Engine platform. That's why we use the false at the end of code. Run the code again, and after a few moments in the layers you will have the MODIs for 2001, a median image for NDWI for 2001, increasing stretch showing that a grayscale image that in which dark region showing the non-water pixels including bare land and also the vegetation cover, as you can see, the negative value, and the positive values or brighter region showing the NDWI value for the water area. So the brighter region or the white region shows the water area and also the water body in our study. So through a thresholding technique, for example, through a manual thresholding technique that I have mentioned in the previous YouTube tutorials I have published in my channel, we can separate the water and non-water actually pixels. If you see the histogram like this, because I suppose that maybe some of you didn't follow my previous tutorial and maybe everything is new for you. That's why I'm trying to explain everything that I know in each tutorial because sometimes finding another tutorial about the thresholding maybe be a little hard for you and also make you a little confused. So through the user interface .chart, as you can see, .chart, we can make a histogram for our image, a histogram for the NDWI 2001, and for the region of the interest with 250 meter spatial resolution. When I run it in the right hand, you will have a chart that is under generation, and after it is created, you will see the range of NDWI values with the pixel frequencies. Here we have a multimodal histogram chart that's showing that ranging from minus to positive values. The first peak actually showing the non-water pixels with negative value, and the second one, as I showed you by the inspector, shows the water area or the water pixels in the image. So this part, the values above 0 or values above 0.1 could be a good border, considered as a good or validate border to differentiate water and non-water pixels. So that's why after that median I use that GT to select those of values greater than 0.1, and after this I remove the histogram code because we don't need it anymore in this tutorial, and then write the code, and this time you will have a mask image that separated the water from non-water pixels. So that's the first step. In the next step, we need to repeat this process for 2023. So call MODIS surface reflectance, we did it. Calculate NDWI median for each date, actually we did it. And in the next part, we want to repeat the same code, but this time for 2023. That's the simplest technique that you can use for the coastline monitoring, and that I'm teaching you. I mean, if you want to, there are lots of rooms about the coastline monitoring that you can go through them, and also just this tutorial is a simple technique about the coastline monitoring that could be very useful in the most of the time if you want to have a check out the changes happened in the coastline quickly and also without complicated equations or methodology. This could be very helpful. So the next one is for 2023. The start date 2023, and the end date 2024, the same variable with a new name and also with a new date, and also the same equation, same threshold, and same technique, and also same visualization process. So that's modis for 2023. The layer name changed to modis 2023. Then run the code, and here we have two binary images. The first showing the lake area for 2001, and the next one showing the lake area in 2023. Unfortunately, this lake highly desiccated over the last years, and but in other lakes the rate of changes is not like this. But you can use this tutorial, you can use this technique for the coastlines in the open seas, and also in the gulfs, in the oceans. And in the next part, I'm going to show you how we can use this for the rest of the world. So, and then you can see that we have two binary images with two different borders, and we need to use a method to highlight the border differences. Actually, the amount of border that we want to highlight the border retreatment over the last 20 years. So here, as you can see, the border highly retreated toward the inside, and I want to highlight these changes through a simple equation. If you studied about the theory, the basic theory of remote sensing, you know that through the subtraction or through the ratio technique, we can highlight the changes between two or more images. That's the simplest change detection technique in theory. Actually, over the last years, lots of advanced and statistical approach developed for the change detection, but here in this tutorial, I'm gonna have focus on the simplest method ever. So, and as you can see here, we want to do change detection in this part, change detection using subtraction technique, subtracting the first image from the second one. Make a new equation, the change equals to, we have two single image. First is the modis 2001 that is subtracted from the modis 2023, and then through a map.add layer, we can visualize the changed image that is clipped based on the region of the interest without and also no need to do such kind of actually visualization parameters. Leave the visualization parameter empty and turn the name, a layer name, from to the lake change, or coastline change is better, because I want to apply this code for the non-lakes pixels in the next step, coastline change, and use the false at the end. Write the run the code again, and here we have a coastline change that's showing the regions that coastline retreated over the last 20 years. Where the coastline was and where the coastline is now, and also this region showing the area that coastline retreated over the last years. And now you can use this code for the rest of for the other water body surfaces. For example, in the Caspian Sea, this is the Caspian Sea. In the Caspian Sea, in the north of Caspian Sea, over the last years, we have some retreated area. We had some retreated area in the north of Caspian Sea. But here, if you select this region, you can see the retreated area in the coastline in this region. Here, you can see that although there are some noises in the water bodies, but here you can see that how much the water retreated over the last years in this region. As you can see, in these regions, in 2001 we had water, and now in 2023 we have no water. And as you can see, but these are noises that typically occur in the water bodies, and you can remove it from the image using making your frame smaller. For example, if I make the frame smaller, or if you use the polygon tools available here, you can ignore this part in region selection actually. So now you will see the new results with the lower noises actually. Yes, there is. And now imagine that you want to actually convert it from a grid layer or raster layer to a vector layer. It's very simple technique. And just let me to back to my main study area, because it is a smaller region, and also I will have faster processing. I will have faster processing because of the because when your study area is small, you can see the results faster, and also without any issues related to actually the system actually the what it was, sorry, I forget its name, user memory limit in the processing. Sometimes because of the heavy processing in the Google Earth Engine, you will face with the user memory limit exceeded error or something like that. But when you select a smaller region, you will face with such kind of errors lower than the other times. So in the next part, we need to change the actually we need to change the cost. Sorry, it is a conversion. Sorry for my mistake. I'm a little confused in this part. So now we want to do a conversion from raster to layer to only have the changed region, to remove the rest of area. Make a new mask and mask the change map using the update mask to remove the no data value. So after this step, using map.add layer, we can show the mask layer to understand it better. Definitely we need to clip it based on the region of the interest and leave the visualization parameter empty. And instead of coastline, this is the coastline change mask. So, and use the false at the end and run the code again. Coastline change mask. Here you can see that here we have a geometry without no data value. This region or these pixels showing the retreated area actually. So now I want to convert it from a raster to vector. Make a new variable, vector equals to get mask layer dot reduce to vector. Helping reduce to images wrong in this part, reduce to vectors. So just low number of arguments needed here. The first is the geometry in which we want to get the vector layer. The border is defined through the geometry here, and then the scale refers to the accuracy of vector layer that should be equals to the spatial resolution, that is 250 meters, and a scale must be 250. In the next part, in order to combine all the multiple layers, multiple vector layers together, use the onion function here, and then through the map.add layer, you will have a one single vector layer for your study area that is available here. And now after a few moments you can see the layer that is created. Maybe it's a little taking time. Yes, and now this vector layer is available. That's this area covering the retreated region for the water body from the border in 2001 to the border in 2023. So the next question is how to export this vector layer. It's very simple again. Dot export to export table to drive. So here the collection refers to the vector layer you want to export. It is vector. Description refers to the name of output file. It is Coastline, actually, Coastline. And the next is file format. That should be equals to SHP, and the next one is the folder that you want to save the results. The folder is, for example, Coastline again, Coastline mapping. So run the code. In the right side, in the task that is highlighted, we have a tab, gray tab. It is Coastline. Run it to start the process of saving results into Google Drive. You can see that the process of saving started. As it is shapefile, we expect to have this shapefile into Google Drive faster without time-consuming process. And once this tab, the Coastline tab, turn to the blue color, such as previous outputs, we can go there and download the results. As you can see, through the opening drive, you will directly go to the page or to the folder as Coastline mapping, and then you need to select all systematic files created, including SHP, PRJ, SHX, and DBF. These are the most important things that should be selected with SHP file. So then right click on and go to download. After a few moments, you will be able to download this shapefile into a single zip file. And as you can see, it is zipped now and it is downloaded in my system. I have it in the shapefile, but I'm using Macintosh platform. It is automatically turned to the unzipped or extracted. But you can also use you can also use 7-zip or WinRAR software to extract the zipped file in your work, actually. So I hope you like this tutorial as much as I do, and if you had any problem regarding to the programming techniques in this tutorial, you can find the code, find my code in the description box below the video in my YouTube page. And also, if a problem still exists, you can reach me out through the YouTube page in the comment part. You can put your comment. I will check and answer them as soon as possible. Thank you for your attention.